All right, everybody, it's 6 o'clock. Welcome to Boostpower TV. Tonight we have a special edition on how to set up your EFI, and we're specifically using the AEM Infinity product. We had a lot of questions written in the past about certain things with in regards to EFI. I'm going to flip over to Jim. He actually can read you some of those questions or give us some info on that. What do you
Yeah,
got?
exactly, Alexi. Like you mentioned, there's been a lot of people, a lot of viewers out there who are interested in EFI. They have carburetors and they're looking to cross over to EFI, and there's just so many different styles, makes. And then comes to the part, how do you set it up, with software and, what are some of these things? So I'm hoping we could talk a little bit about that today.
All right, very good, Jim. Thanks. A lot of people they have carburetors or they have a stock EFI motor, and they want to make that cross into what we call the dark side. Going over to EFI and being able to tune it themselves instead of relying on some mail order place that doesn't have a dyno through the telephone or that frustration. So we wanted to take a little bit of time and show you guys how to set up a basic engine wizard so you can get a better understanding on how to set up an engine for the first time when you go to start up an EFI conversion. This will help anybody, whether it's a pro engine builder, a basic hobbyist, or anybody that wants to fuel inject any type of vehicle. This is the best way to at least give yourself an idea of how the brains work inside the computer. You guys have all seen random EFI computers, but here's the inside of a brain right here. It's a bunch of circuit boards and computer chips, and a lot of the memories are in these little chips, and especially in that big one. So it doesn't matter what brand EFI you have or ECU controller, they all need a basic setup parameter before you start them. They're just basically a robot that you need to tell them what to do and look for. You got to explain to the computer that you have this sensor and that injector and this firing order, and then basically when you put in the order, it sends the signals out through the wire harness to the proper areas and makes the engine start. So every brand out there has some sort of a setup wizard or setup page. It just depends on, obviously the brand and the type of sophistication they use in their software. There's consumer level and there's engineering level software that may or may not be available to the public as well, which gets very in depth with certain things that may confuse a new EFI user. So because AEM supports us so well and we're very much proud to run their product, we chose the AEM Infinity Series ECU Wizard to give you a tutorial because it has a big screen and it has a lot of options, and they call it Infinity for a reason. So we'll go through this one and we'll review other brands in the future, but we want to go through this one so you can get a better understanding of how to set it up. So I'm going to flip to a screenshot here and give you guys a bit of an idea of how this works. So for example, you'll pull up a basic setup screen like this on many different brand EFIs that asks a lot of questions. For example, this particular engine displacement is a 307. We could put 540, we could put 572, pretty much whatever you want you can put in this location here. And then, of course, the number of cylinders, that's very basic, but most of them have a drop-down menu, and if you want to go more than 8 cylinders, there's certain levels of software that you can get that allow that as well. Of course, you can do 4-stroke, 2-stroke, so if you want to do an outboard, you can choose 2-stroke if it's an old 2.5 Mercury or some kind of motorcycle. This is the important thing here, understanding the ignition type you're about to use. So some have a distributor, which is pretty common. Some have coil on plug, which has 8 coils, usually on a V8 engine per cylinder. And wasted spark, which is like your 525 Mercruiser. It has 4 coil towers with two pins on each one. So basically, one coil fires 2 cylinders. So you can make that choice right there simply through the computer. Moving right along into the firing order, you can pull down the drop screen menu here and you can choose several different firing orders. And of course, if you wanted to, you can customize your own firing order by simply going to the cylinder and setting the degrees in which they fire for an 8-cylinder. We've pulled up an 8-cylinder basic map if I didn't explain that before. So moving right along to airflow calculations, a lot of people use volumetric efficiency, and there's several other options here, but most of the time new users will use the VE type tuning, which makes it easier and simple to follow. When you go into the main spark map and load axis, a lot of people use map, which is load, and they use it in kPa. Some people will flip to barometric pressure if they're used to PSI and vacuum. A lot of the other brands only allow the kPa and don't use barometric pressure. This one gives you a little bit more of options for that, and some of the other brands do as well. If you use the VE table load access selection, you can basically change any of the axes on any of the lines in any of the maps by simply choosing your choice of how to tune. Now, if this is your first time, I recommend just using kPa on here and kPa on here for both your load and your VE. That just keeps everything in order for you to get a basic understanding of how to tune your engine. Alright, so we're going to go back over into the next step here, which is tuning preferences. This basically says when you turn the engine off, do you want it to upload your changes? I usually leave this checked off. I want to save it and upload it at will. The only thing good about this, if you check this box, is if for some reason you stall the engine or something and you didn't save it on your computer and the power goes bad all at once, it might be an option for you to check, but not too big of a deal there. But going into the cam and crank, this is your ignition setup. So if you go to show details, you have a lot of options here. So for example, if you have the EPM unit, which is the AEM, it replaces the distributor and has a 24x signal in it, then you simply choose this. But if you look, there's so many options from BMW to Dodge to GM to Honda to Mazda, and it just goes down a huge list. All the strategies in here are already figured out for you. So for example, if you wanted a 60-2 similar to an LS pattern, you can go over here and you can verify that your sensors and everything is set up. It says here 60-2, missing teeth. It gives you all the specifications so you can line up your wheel on your crankshaft. But there's so many options here. You just have to make sure you know your cam and crank signal. And if you know your cam and crank signal and where it's located, you can get it real close by setting the basic cam and crank signal and then basically show the details, and you'll be able to set it up so the computer can see where your trigger wheels are set up. Now if you have a regular distributor, obviously you just choose like a mag trigger if it's a locked out MSD. So there's all kinds of options to set that up in this wizard area here. Alright, so always stay simple with that. Don't go overboard. Just find out from your trigger manufacturer how many teeth you have, whether it's a VR signal or a mag signal or whatever it is, and then it'll be very self-explanatory there. Alright, so when you go into the injectors, for example, it says primary fuel pressure reference. So that means, do you have a fuel pressure regulator with a hose going to the manifold, or do you have an open hose going to just atmospheric pressure? So the computer wants to know basically if your fuel pressure is static, say at 50 pounds, or is it going to be moving around based on vacuum, which changes the way the injectors pulse. This actually has the ability to calculate based on vacuum how much pressure is going to change based on a fixed position there in the ECU. So it actually calculates the richness and the leanness and compensates into the VE table. All right, so if you look here, primary injector flow, so you can pick your fuel injector. Again, when you go to your receipt book of where you bought your fuel injectors, you can simply go and find out, okay, I bought a, let's just pick one, all right? Let's just say I picked a Injector Dynamics 84-pound injector. When you put that in there, it basically populates everything that the computer needs to know about that injector, and it tells it what its performance is. And you can look and see some of that information here. And if you don't have one, then I recommend picking one that is as close to what you have spec-wise as possible. Talk to your manufacturer, and you can compare some of these brands with those and get it real close. Obviously, you'll be fine-tuning it in your engine when you get ready to fire it up. You'll be adjusting for that. The other thing too is, like this is your primary injector duty limit right here. What this means is no matter what, you'll be maxed out at 80% of your fuel injector's capability. It's a good rule of thumb to make your maximum at 80%, because if you go to 100%, sometimes the injectors go static, and when the injectors go static, it creates problems and they just start flooding the engine and you don't know what's happening. All right, so this is the number of injectors. So this one says 4. Obviously, if you have 8 injectors, you put 8. Primary fuel type is gasoline. Now, if you want to run flex fuel, E85, methanol, and it tells you here the difference in the stoichiometric ratio and the specific gravities for each one to make sure that you're calculating the correct VE for the basic startup of the engine. Kind of a neat feature there. The other thing is phasing. So if you look here, it says injector 1 primary phasing. It's telling you where in the engine firing order that these things are phased in at. So this can all be manipulated later on in more of an advanced setup, but usually if you just pick a V8, it basically has this standard sequence of events of when the injector is opening. Now you can change that in the software while you're running it on the dyno. You can turn the injector cycle on early, late, and there's a lot of hidden horsepower there if you get to that level. But this is just a basic area here that shows you that. All right, so moving into basic sensors. So what you want to do is, again, you must go back to your receipt book and say, okay, what air temperature sensor do I have? So you double click on that and you basically look here and it gives you a graph of how the sensor works. So let me move this up a little bit. You see the graph? So it's telling you how that sensor's set up, and these numbers here are basically each position. So if you pick like an air temperature sensor from GM or AEM or whoever makes it, there's a drop down menu again. So it tells you here, like say you have a Toyota sensor, it's got the information, or the LS2 GM, you double click on that and they have it populated already here, so you don't have to do anything. We already know the statistics of that sensor. Especially obviously if you use the AEM brand, if you use their 3/8 deal, it shows this curve and all the numbers are here, and that's all you have to do, and then simply close that part of it and then go to the coolant temperature sensor. When you go to the coolant temperature sensor, it's the same type of thing. You just literally pick what it is that you want, and you can adjust these numbers and you can change the curves around to make it suitable for your needs for each sensor. Same thing with the map sensor. You double click on that and you can pick what type that you're using. So this one is very important. This one is set up for a GM single bar map sensor based on its part number right here. And if you just hold the mouse right there, it's basically telling you what it is. It says it sets the calibration for the maps and it gives you the spec. Now, you might have a GM 1 bar that's something else. There's another one here. There's another one here. There's several of them. A lot of people A lot of people think that the map sensors are all the same, and they're not. They're definitely different. A lot of the GM sensors, they can be plastic and look the same, but they actually have a different curve. So it's really important to look, when you double click on this, you need to check this curve out and make sure these numbers are correct for your application. So don't just assume because it's a plastic sensor and it's a 1 bar that it's going to act the same. A lot of times people change sensors on a stock motor and they go to Napa and they buy a single bar map sensor from some Buick and they think it's going to work on their motor and they end up exploding it because at 3,000 RPM it's a 1/4 of a volt different input to the computer and it runs lean there. So be real careful with that. It's really important to get this set up properly. Alright, so let's get out of there. Let's see. We're going to go back into this tuner here. And let's see. We gotta make a couple adjustments here. Alright, so what I'm going to do is reopen a different part of this software so we can see it a little bit better. And let me see if I can show this to you. Yeah, all right. So again, when you're looking at certain things on the fuel, basically your VE table and see, like this is in negative vacuum and positive. It's in map PSI. So if you change this to KPA in the wizard, this all becomes KPA. So you have to be familiar. Like if you're a new EFI user, you may understand that this is 0 and 1 pound of boost, 3 pound of boost, 4 pound of boost, whatever. Where if it's KPA, you may not understand it. So, there's a lot of ways to play with it. But basically your idle range, and when you fire it up, if it's lean or rich, you can simply highlight a section like this and then simply move the map up and down. So I kind of wanted you to see where that wizard applies for setting up the sensors and the injectors. So I hope you understand that. Like when you set up the, if you look here, when you set up the injectors and all this stuff here, if you click out of this, what I was trying to show you is this section here is where your fuel is. And if this section is where your fuel is and you're running and idling, you can simply just hit the minus or plus button till you get the engine running. And what that does is it manipulates that injector pulse. And once you manipulate the injector pulse, then you can see what's going on with the, you can home in on that air-fuel ratio for your injectors. But try to set all this up right. All right, going back to the fuel pressure sensor. A lot of people don't run these, but we do, and we like to be able to know what the fuel pressure is doing. So you can minimize this, and again, you can put your calculation minimum, maximum, or for the first time users, you can just pick a sensor. This one's set up for an AEM 100 PSI sensor. Comes with a lot of Whipple kits and a lot of supercharger kits out there, and you have the ability to change it to whatever you want. Or if you don't see one and you know what these specs are, you can basically call it an AEM 100 PSI, but it can be anything. So the ability to change it on the fly and do whatever you want is a big benefit. So that's kind of a neat feature there. Same thing with the oil pressure sensor. You can turn around and take the oil pressure sensors and move them around and do the same type of thing. This one's set up in a certain range. So that's pretty basic. Hopefully you guys can see that, but I want to go through each thing so you understand how to set it up for the first time. All right, this one's the throttle position sensor setup. Throttle position sensor is set up the same way. It basically is asking you what type you have. This is an analog, and it has the minimum and maximum volts. It's pretty typical to have a minimum of 0.88 and a maximum of 4.47, but sometimes the voltage is 0.45. So you may choose to lower that. You just have to, when you set up and key on your deal, you need to see what the voltage is when the thing's at idle, about where you think the throttle position would be. That way you can adjust this if need be. But usually this is a good starting point that the wizards default to in most EFI programs. All right, So this is for drive-by-wire tuning. Most of you guys are not using this yet, but basically this sets up the drive-by-wire calibrations in the engine here. So if you have no cable and just a drive-by-wire throttle body, you can go through each one of these setups here to make sure that when you start the engine that it knows what it's trying to control as far as the drive-by-wire setup. Alright, so if you look here, a lot of the newer EFI systems have this. It's a set throttle range. So when your engine's all sitting in your boat or car or sand car or whatever it is, and you want to set minimum and maximum TPS voltage, you basically come into here, key your engine on, hit this button without the throttle depressed at all, and then it'll prompt you to go all the way to wide open and then set the maximum. When you do this here, you'll see these numbers change here. And what it's doing is it's saying, okay, we know this is the minimum throttle, we know this is the maximum throttle, and now this is our fixed range based on this person's vehicle, ECU, harness, and software. So it's very important before you try to start this machine that you set this up in the wizard with the key on, and when you're connected live to the ECU. It lets the computer know what range it's going to live in. So some of the guys forget to do this, and then they go do all this tuning and find out that they're way out of range and they got to start over. So please go through these wizards and basic setups in any of the software before you go to start the engine. Alright, the other one you got to know about is ignition sync. So what this is say you get the engine up and running. When you get the engine up and running, you want to do what's called an ignition sync. So you want to check this box, and this one says 15 degrees. What that means is that it's going to hold the ignition at 15 degrees. So say you're up and running and the air-fuel ratio is pretty close and you have no leaks and everything's cool and safe. You basically take the timing light and it should be at 15 degrees at any RPM. It locks that distributor down. So at idle it should be at 15 degrees, and at 3500 it should be at 15 degrees. That way you can ensure that you're synchronized with the computer to make sure that you have this number here of 15 matching the timing light. It's really important that you synchronize this before you do any continual tuning. So get it up and running, put this in timing mode, check the timing and make your adjustments on any distributor or cam teeth or anything. So if you go here, for example, say you have a 60-2 wheel, well, you can change the offset right here in increments to change the timing. So because you can't adjust the timing on a reluctor wheel on the crankshaft, but you can change the offset right here. So between this little area here, while the engine's up and running and idling, you can synchronize the timing. And if it's fixed position, then you have to do it here by telling the computer that, hey, I'm off X amount of degrees, so I need to offset. Say you're at 18 degrees, you may want to offset this number up or down to get it in sync. Once you're done with that, uncheck the box and save everything. That way you can make sure that all this adjustment that you're doing is ready to go and set up for your next startup and final tuning. Alright, so now we're going to go into the advanced setup over here off to the left side. You can see it right about there. So we did the ignition sync. Now this is your acceleration and deceleration. Now most of this stuff is more advanced, and obviously we'll go into more depth about it at a later date. But basically in the accel decel fuel, it basically says here that you're going to be able to set your acceleration fuel by the throttle rate and the engine speed. But again, you can change it from coolant temperature, you can change it from the rate of change, you can change it from what the load is. So there's a lot of ways to adjust this. I always think that the best way to start out on a new tune is throttle rate and engine speed. That way you can just basically feel out what the engine wants and get it crisp and clean accelerating there, and then move into any further tuning in the layouts. And then over here you get into deceleration cut. So when you decelerate, this means that this box is checked, and it's going to go ahead and, when you're below 2.0% of fuel, fuel or throttle position, that it's going to maybe cut fuel. So you could turn all this on or off. I always recommend leaving these at default in the beginning, and then once you think you have a pretty good tune on it, then you go in here and, of course, do what's called the advanced tuning. So if you look at advanced trims, these are, again, these get into all kinds of in-depth parameters that we will show you at a later date. This is more of the advanced session here with these drop-down menus, but I'll skip around and go to the basics for firing it up. Most of the guys aren't running turbos in the beginning here, but this is all your boost control. This is a hot one. This is engine protection. So enable mill output. That allows you to have a ground output to a light or your Merc Cruiser buzzer or whatever's existing on your boat. So you can check this box and have it work the same way. And then you can set maximum boost, throttle position, temperatures, lean, rich, however you want to input any kind of alarm into that output. You can do it right here. When you look at some of these other spots here where they have, it shows you like idle on below TPS. For example, if your throttle position is below 5%, it basically tells the computer you're trying to idle, so put everything into the 850 RPM range or whatever it is. So these are the type of things that you can manipulate if you have to be, say your engine wants 5% of throttle just to stay running, if it's like a 700 cubic inch something rather. So you got to change this and move the number up to like 6 or 8%. This will happen after you get up and running. You'll see that you're not being able to adjust too much fuel, and then you'll have to come back into the wizard and do more advanced things. The input functions, all these things are whatever you want to input into the ECU for any kind of change or modifications. There's switches here, there's speed and frequency, temperatures, and axis for tuning. So these are all custom tunable inputs, and there's also outputs. This one here is pretty nice to put on, but I don't put this on until after it's tuned, because you don't want your knock feedback to start manipulating what you're doing on your base map. You got to get the base map set up. So it's really important that you get the base map set up on these EFIs, and don't turn all these extra functions on until you get the basic engine timed, running crisp, revving crisp, idling good, or as good as you can, and have a stable engine that'll actually start and run and idle. And once you get that going without your O2 feedback, in other words, have the oxygen sensor feed back the air-fuel ratio to you, but don't let it take over and make any adjustments. Do it open loop so you can get a good baseline, so if any of the sensors fail, the engine runs good. That way it's not, all of a sudden a disaster if it goes into a limp mode. So part of the thing you got to do is understand this section here. So, this is all set up and basically turned on for the knock sensors, but I have it unchecked here until I'm done doing the base tune. Once I do the base tune, then I can turn this on and then run it and see whether or not you have to change the sensitivity of the sensor and what you want it to do. This is basically saying, like, if it knocks, how much timing am I pulling out down here? 8 degrees. If I have to have a minimum throttle position of 40% for it to even work. So you can say, look, I want it to show me a knock at 20%. So you lower the number, but it's going to be more sensitive, and you definitely want to do that normally after it's in the boat or in the vehicle, and you can actually monitor it real time, because there's a lot of things that vibrate and make noise that will false all of this, and then it's a problem. And if you have this box checked when you're doing your basic tuning, you could be knocking and you keep advancing the timing, and when everything's right, all of a sudden you're at 45, 50 degrees of timing because this thing was pulling timing out trying to help you, and now it's not. So don't make the mistake of having this stuff on when you're doing your first initial setup. It's a bad practice. Make sure you get it all based up and running, and then turn this on and the lambda feedback and all that. So here's one we can talk about for hours, but this is the lambda control. So this is your air fuel, oxygen sensor setup. So this one says it's installed. This one says it's turned on. And this means here, how much will it possibly correct no matter what I do? So if I'm running on the dyno and it needs more fuel, it's only going to add 15% of fuel no matter what. So if I'm 25% off, I'm going to be 10% lean no matter what, because I only have 15% of fuel here. So a lot of times we'll put 40% here and 15% to take away. So we can't ever lean the motor, but we can sure add a lot of fuel. So you can add 50% of fuel for basic tuning, but over here you don't want it to take away anything. So again, I don't normally tune them in closed loop, so I leave this feedback off, and we use external AEM meters and get them close, and then we try to get them perfect, and then we turn this on and we tighten these parameters up to be able to add 15% for any kind of a fuel pump issue or anything, and only take away 5%. So we tighten this up. The other thing we do here is we set it up to where the minimum speed for the sensor to even do anything. In a boat, you got to keep this up around 1500 RPM or it'll lie to you at idle. A lot of times you get false readings until you're under load and on plane at about 1800 RPM in a boat. So a lot of times we set this to 2000 RPM before it does anything. You'll see that in your boat, if you have a sensor, it'll sometimes act like that. Alright, so these are more advanced features down here we can go into later, but having this on or off is basically right here. You just turn this sensor off, or you leave this one on to let it know that it's there. You leave the feedback off, but when you're looking, when you're tuning this engine, if you look down here, over here it'll tell you right here, when you're running the engine, it's still showing you like, hey, it's running 12.5 or 13 or rich or lean right here, but it's not going to correct or do anything. This feedback number is not going to help you. So you can simply say, okay, we're running lean right here. Okay, so then you simply hit plus. See how the numbers are going up? All I'm doing is adding fuel, and you'll watch over here that the number from say 13.0 will come down to 12.5. And once you look at that, you can say, okay, look I'm at 61 now. To make this right, I want to make all of this richer, right? So you simply can highlight it and you can hit plus like that, make it 62, 63, and now it's smoother, right? So before you smooth all this in the map, there's functions that we'll go into that, you can right click, right? And then see where it says down here, you can't see it, but it says smooth. So you just hit the smooth 4-cell button and it automatically smooths this section out right here. So there's all kinds of trick things you can do, but basically say you start it up and you're idling in this range and it's rich or lean. Even though the oxygen sensor is not going to do anything, because we don't like to believe them at idle on a boat header, you can simply go up and down and you can watch the power or torque on a dyno move. You could be going one way or the other. You'll see the air-fuel ratio up here changing. And then once you say, okay, well, like for example, what if you're idling right here? Say you're idling right here and you're way lean and you say, okay, this thing really wants a lot more fuel. This thing, okay, now it's happy around 80, right? Compared to the 40 it was at, right? You definitely don't want these numbers to be any smaller than that. Usually you want to start out and basically get these back up there. That way you have a smooth transition, because as you go up, usually your load is going up in here. Your load range goes up, so you don't want a lean spot. Once you start loading the engine, you'll start to see this box follow up and into this range, and it follows you around where you're driving. So on the dyno, we simply just follow this box, and then we say, okay, we're going to run in here now, right? So we'll simply just highlight this. We'll load the engine and drive it right into the middle of this hole here, and we'll simply lean, rich, watch the horsepower numbers go up or down, set this number where we want it, and then once we get this all done, we do it with the timing, and then we go further into the timing in each hole, into each cylinder, and then you can go into cylinder trims. I mean, you can go into, you know, all kinds of things. You can go to each cylinder. This is per cylinder offset. So you can, I mean, it's unlimited what you can do, but we'll go over that more in the advanced session. But we wanted you to see and understand how some of this applies to that. All right, so that's the lambda function there. And then, you know, launch control and anti-lag. You guys in the boat market don't use that, but some of the sand cars do use it, and some of the hot rods use it. So you can have a launch retard for the timing available, so you can hold the throttle all the way down. All kinds of trick things you can do with this function. You can do a launch timer, which is this one. Nitrous inputs. So a lot of times we use these nitrous inputs for methanol injection. So, you know, just because it says nitrous, you can make this control anything. So basically, when this computer sees an input from some kind of a grounded wire, it adds X amount of fuel, and you can go simply to one of these tables behind the screen here and add fuel based on you putting methanol, nitrous, cryogenic, intercooling, whatever you're doing to upgrade your engine. So again, these are features that you'll just leave off in the basic function of starting your engine. But you got to kind of scroll through each one. So this is one that's popular that we get calls every day about. Can you move my rev limiter up? Can you change my rev limiter? I want it 200 RPM higher, 200 RPM lower. Well, if you have this system, it's real simple. You have a fuel cut and a spark cut, right? So the reason there's both is so you don't overshoot. I'm sure there's a lot of you watching that have broken engines because the outdrive broke and your engine overshot. Well, that's because maybe you only have a spark cut. If you have a spark and a fuel cut, you have a better chance of the thing overshooting by 1,000 RPM. You know, if you're running 5,800 RPM and you break into neutral, it's going to definitely overshoot 6,200, but you might only get to 64 instead of 74 because they'll overshoot that far. So the other thing you can do is set a retard. So when you get close to the maximum RPM, say of 6,000, it starts pulling the timing away just a little bit to make that hit a little bit softer on the engine if you do hit the rev limiter. So there's a lot of stuff here that you can do, and then if you hit the advanced function, you can really home in on making your rev control really smart and how it reacts. There's all kinds of advanced features down here that you'll read about later, again, after your basic setup. You have a two-step rev limiter, so you can do things for different inputs. That's pretty basic. There's a third step you can add. Shift cut. This can come in handy for you number 6 drive guys out there or anything with a heavy load. When you shift the engine, you can make it do several things right here. You know, like you can retard the timing for a split second. You can ramp things. You can have it do anything here. You can have it fuel cut. There's all kinds of things you can choose for shifting. Some guys like to idle around 1,200 RPM, but they can't shift. So if you want to idle at 1,200 RPM, you got to do a fuel cut input, and then you can pull this menu back and go into the, you know, some of these special options that are all throughout this tuning, and you can see that you can choose all kinds of different things to play with when you're trying to do any of that type of setup for your engine. So again, having that control and the ability is a nice option to have. All right, so traction control comes in good on like a Mendiola deal in a sand car if you want to, you know, or some kind of traction control transmission that you might have, whether it's custom or aftermarket with a computer controlled clutch. There's all kinds of options. A lot of the boat guys don't use this, but the function is there. When you go into USB logging, this thing can data log for eons. I mean, you can plug in a USB stick right into the ECU, and it's pretty simple. Like a lot of people call us and they say, "Well, how long can I log for? You know, my ECU overwrites after 20 minutes." Well, on this ECU that AEM has, there's a couple ports here, and one of them is a USB port, and you could plug it into an external terabyte hard drive if you want it in your boat, or some of the really small. They have really small thumb drives, we call them, that hold a lot of information. So you may consider that. Going back to this just says how many samples per second do you want to data log. And then basically you can have it turn on automatically based on this or that, or all kinds of options. And then again, you can always click advanced and scroll down for miles. Okay. So a lot of the marine guys, they don't use variable valve timing, but you know, a lot of the new engines out there that have 4 cams, they do have variable valve timing. And if they have phasers on them, we can control them. So like if you have phasers on you know, 4-valve motor, some of Mercury's products have phasers, and some of the other aftermarket engine companies have phasers. I know BMW uses a lot of them. You can modify the phasers so you can seek the most horsepower out of your cam phasing. So basically this manipulates where the cam position is in the rotation of the engine. It's a pretty advanced deal right here, because if you screw this up, you can have valve contact with pistons. So you got to kind of know what you're doing there for sure, but the option is here. So the thing to have a look at is your Diagnostics tab. If you look through here, you know, there's all kinds of things you can set: crank RPM, you know, battery filter, shutdown time, speed. You'll have to read about this, but again, don't mess with any of this stuff until you start the engine up and get a base map on it, because there's a million options there, and we don't want you to have any trouble. So one thing I just wanted to give you a quick idea here. So like when you have the timing set up, I showed you the fuel. So when you have timing set up, say like this engine idles pretty much right in this 5-degree range, right? You can see that this is where we've stabilized this engine. So when it's running, it's basically bouncing around in this area, right? When you rev it, it kind of just jumps up here and jumps up here and jumps up there. And then when you put it in gear and drive it, it starts doing this and moves up and goes into there. So if you think about a distributor, right? A distributor is usually going to be 5 degrees all the way up here and move its way into 34 degrees based on springs and weights. With this, you can have it 5 degrees here, and you can have it 23 there and 21 here. This really gives you a lot of options depending on what you're doing with the motor. But for example, say you're at wide open throttle and you're in this range, right? And you're watching the dyno, and all of a sudden you're saying, okay, I'm making 1,000 horsepower now. That's pretty good, but let's see if we can make more. Our air-fuel ratio, which I showed you earlier, is already set and done. You can simply add a little bit of timing and see if the power number goes up. You may not get any more power. You may find that if you go from 35 down to 32 or lower, that you're making the same power with a less chance of having detonation or knocking. So once you get to this level, you want to be monitoring your knock, because you can see it in this area here if you have it turned on, or you can simply click the knock control and you can snap one of these screens out. So see where it's blue, it says knock sensor. So this basically will show you where you're at in the range and where this engine is knocking or not while you're doing the test. You may find that the engine knocks at, you know, at a lower RPM or a higher RPM, but basically this is where you find all the power. You know, a lot of guys say, oh, you know, what's good about EFI? Well, you can change the timing here. Say it's happy at 33 here, but down here under a lighter load, it needs to be at 34. Because at that load, the horsepower is down. You can't do that with a mechanical anything, no matter what. You can't change those things in those ranges with all the different profiles. You can change it from here to there and, you know, curve it, but like this is at wide open up here and this is at cruising speed. Well, if you're still at this RPM with a lighter load, say you're not climbing a hill, you may want the timing advanced. Well, you can't do that unless you have computer control. So, and you might find out that up here the thing wants to be at 31 degrees, right? So now it's at 31 degrees and the thing's making max power up here at a lower amount of timing. So again, you can't do that and find the horsepower unless you have EFI, because it's just not possible. You can't take a mechanical weight and change the load and have it come into here. So, you know, guys will dispute that up and down, but we do it every day and we see. But interestingly enough, you may do this for a different reason. You may say, look, when I'm at 0 vacuum and cruising right in this range here, I want better fuel mileage. So you may put the timing at 26 degrees right there because you don't care how much power you have there. You know that this is the area you drive to the Pirates Cove or wherever you're going in Florida, you know, to the Tiki Bar or down to the Keys. You know that this is your cruising range right here and that you want maximum fuel economy there. So if you adjust this to knowing that that's your cruising range, and you see you're over here at 0, you can simply come over to the fuel, right, which is your VE table, and come down to 0 and say, okay, well, look, this is that area where I want to get fuel mileage, but look at the numbers ramping up here. So while you're running it on the dyno or in your boat, you can simply say, okay, I'm going to lean her up a little bit here because there's no load really much on the engine. I'm not making but 1 pound of boost or vacuum, depending on how you're set up. And I just want to lean her down a little bit right there. And as long as you're in a safe range of 12.5, 12.6, and you're not loading the engine, that's fine. Now you've resolved your fuel economy right in your cruising range, knowing that's your cruising range. And then you can come down under here and basically adjust it, smooth it, change the numbers up and down, whatever makes sense as you test it. But knowing this is good because you can take that information from here in this grid and you can copy it over to your timing, which is important. You know what I mean? So that way you can maximize your fuel. Now again, there's all kinds of adjustments on here that you may or may not use. I mean, a lot of this is confusing, right? But for the first time, I always tell people you want to concentrate on your VE table, which is your fuel, and you want to synchronize your timing and make sure your ignition map looks good. You know, like you could come in here and set this thing up real simple. You can just come in here and go, okay, let's just pretend we're a distributor. We want to idle at 15 degrees and at wide open throttle we want it to be 34 degrees, and then let's just take this number here and properly interpolate it horizontally. Okay, now this is a distributor. This is a typical MSD distributor with a blue spacer and 2 light silver springs. Basically based on RPM, if you look down here, okay, at 2500, right at about 4500, you're at full advance. Your idle range is 15. I mean, this is a good starting point for any engine. You're basically saying, okay, we're going to start it up and it's going to run like a carbureted deal right here. And just to make sure that everything's cool. And you're going to come over to the fuel and you're going to say, okay, I have my fuel in this range here. And this is my idle range. And then basically when you fill out the wizard with all the fuel numbers, it'll populate this, and then like I said, you'll say, okay, this is where I'm idling, this area here. I'm going to move this up and down till it gets stable enough to set the timing, and then we're going to go on from there. So hopefully that gives you a little bit of an idea of how this thing thinks. They're all thinking about the same way, depending on a few things, but most of the brands. And with the AEM, you have a gauge set here, so you can move around gauges and adjust different things and output different things. And the other thing too is, like, if you want to start your engine, you can go over here and you can adjust all kinds of things. How much percentage of fuel you want, how you want it to start, where you want it to idle. All these numbers are adjustable. Like, so, if it's 32 degrees till it gets to 104 degrees, you could turn around and say, all right, I want this thing at 1211 RPM. And there you have it. As soon as it gets to 140 degrees, it's going to drop to 850 RPM. So it's pretty cool that you can adjust for any of that. And what that basically does is adjust the timing, moves the idle air motor around. It gives you the ability to do different things. So again, once you sort that out, you'll see that it makes sense. Now, once you turn the closed loop on, once you get your basic tune, you'll want to make sure before you start, you set this up to a safe parameter. For example, this is a normally aspirated engine. At wide open, it's happy at 12.3 air-fuel ratio. Under light load, it likes to be in the idle range. This one's actually on at idle, and it's 13.5, which is on the lean side for a big normally aspirated marine engine. And then, as it goes down here in this range here, it's 12.9. Now, this is not correct because this is a lighter load. So to correct this, you would say, look, the leanest I ever want this thing is 13.49, right? That's the leanest you'd want it under no load, right? And then as it gets richer at wide open throttle, you want it, say, at 12. Let's just call it 12.2. Let's make it real conservative, right? So we have it at 12.2, and then you can simply highlight this grid, slide the mouse up, right click. You can't see it, but it says Interpolate Vertically, and what that does is that curves it to where basically it's going from lean slowly into a richer area. That'll keep you safe. Now, once you set this, you can look where I was telling you on the VE table over here. You'll be able to look in this area here to see if your air-fuel ratio, basically how much is it adding? Is it adding that full 15% we talked about to keep it where you want it? And if it is, you can see it real time where it's happening. Like say it's flashing in this area. Say it's running really perfect on the dyno, but down here the feedback says, man, we're adding full 15%. Well, in that case, you just simply come over here, highlight this section, and basically go up on the fuel, and you'll start to see in this area here, you'll start to see that the feedback number comes down and the air fuel meter here stays the same. But you'll see you want the feedback numbers to be like 0.0102 to 0. That means that if the sensor goes bad, it's only going to be 1 or 2% off. A lot of guys tune the engine and they leave the sensor on, and when the sensor goes bad because lead kills them after a while, all of a sudden they're stuck. They can't run, their motor doesn't drive right, all kinds of weird things happen. So, it's really important to do it in steps. So, I can't begin to tell you, take the time to do this in steps. It's really important to make sure that you know what injectors, what sensors you have, what mechanical items are on board, your fuel pressure, your regulator. If you follow the steps I just showed you, no matter what brand you choose, and you input the information, assuming the brand you choose has all the curves and corrections in it, some do, some don't, and you do all the basic things in order, and don't turn too many features on in the beginning, just leave the basic fuel and timing and some of the basic things in your rev limit and all that set up. You get the engine up and running, move the fuel around, stabilize it, synchronize your timing, check for leaks, take breaks in between, save your data, make sure you save it before you shut it off, or, throughout your tuning. And I always recommend saving it under a new name each time until you get it exactly what you want, because a lot of times you make corrections that are no good and all of a sudden you've gone backwards with all the expensive time on the dyno. You don't want to do that. The other thing is, once that's done and you feel as though it's revving and idling and starting and cold starting the next morning, then go into the advanced section and start playing, because that's where you find the horsepower, that's where you find the better running. That's when you can change the air-fuel ratio in each cylinder. That's where you can change the timing in each cylinder. You can actually set the time in which the injector turns on and off in each cylinder. So you can actually look at your cam profile, and based on when that cam opens, you can tell the computer exactly when to open the injector. So like if you know that, for example, I'll use just random numbers. If you know at 25 degrees that camshaft is just now starting to open the intake valve, you may want to start that injector time at 24 degrees, about 2 degrees before that valve opens. That way, all that fuel is going directly into that motor and not puddling behind the valve because it opened too early. So a lot of engines out there, they're EFI, but they're shooting the fuel in way too early based on some generic random phasing number that someone put in there. It'll start and run and it'll sound good, but if you set your phasing, which you can do on this AEM system, and a lot of the other ones do it, but if you get a hold of that and get it right and matched to your camshaft, you save a lot of fuel and you can make a lot of power without burning a lot more fuel. It's just the timing of when you inject into the cylinder. So I want you guys to think about some of these things we went over. I hope I explained it to you in such a way where you can get yourself stimulated to download some software of any brand and start picking through each folder and file and see what options are available and try to get familiar with it, because familiarity is half the battle. A lot of you guys out there are scared of EFI, and I get it. There's a lot of money at stake when you damage an engine tuning it. It's costly. So I always recommend taking it in baby steps. Don't be in a rush. Make it a long-term project and learn it, because once you learn it, it's like an addiction. You're going to go in there and you're going to make changes. You're going to drive a car halfway 3 or 4 hours across the state and make some adjustments, come back. I mean, every time I drive somewhere, I have a laptop on the dash, whether it's a diesel truck, my regular vehicle, someone else's car. I'm either collecting data or checking to see what others have done for their tuning, including factories. I mean, you learn a lot from some of the engineers out there in the real world doing things for emissions. So, it's really interesting to see. So I recommend digging in deep, and don't be afraid of it. Hopefully that gives you a basic session on how to do the basic setup of most EFI systems. And we'll go into more tuning. Maybe next week we'll talk about a little more tuning. We'll go through the tuning maps and give you an idea of how that works. And they're all pretty much doing the same type of thing. It doesn't matter what brand you have as far as what it is that you need to adjust to make the engine work. But some systems have less, and some systems are advanced and have way more options. So the ability to have more options and control of your engine gives you a better net result. So we always like to say that there's a reason that this is called Infinity. It has a lot of options. I mean, you can literally make this thing control or do anything. We just put one on a Polaris Razor. So, I mean, it can control anything. Two-stroke, there's not a lot of ECUs that properly control two-strokes. And anyway, they're not all this small. So keep that in mind. If you have any questions, don't forget, write Boostpower TV at boostpower.com. Any of the questions that you might have, we'll be happy to answer them periodically. We're going to start doing a little more product review, some tutorials and different things. If you're a manufacturer of any part and you want us to review your item or discuss it, simply just send it in so we can do it. Don't feel left out. Send it in. Just send the product in that you want us to review. Give us some communication. We'll be happy to do it. AEM sent us this Infinity system and the software, so we're talking about it. We also have a great relationship with them, and they're our choice of ECU on our engines. So we chose to use that. If there's any other questions that you have in regards to the show, just email us again at boostpowertv@boostpower.com. We're trying to do it every Tuesday night at 6 p.m. Pacific Standard Time. Check the GMT conversions for all the international folks out there that are following us. Thank you. And it's usually available an hour after the show to replay either here or at YouTube at Boost Power Marine.